Welcome to this demonstration on how to advertise to the internet AI inference models using OpenShift AI and F5 distributed cloud. We start our scenario with one or more deployments in the public or private cloud. How can we advertise to the internet these AI deployments using a single VIP? How can we do this easily and securely? Using F5 distributed cloud, exposing an AI inference service is no different to any other application. The only thing it is needed is deploying a component called customer edge in each site. Customer edges can be deployed as VMs or as pods. These customer edge sites are connected to distributed cloud's regional edges, which allows to interconnect the customer edges between them and also provide internet access with the advantage that distributed cloud provides IP anycast VIPs. This means that multiple inference services hosted in different sites can be advertised to the internet using a single anycast VIP available in all F5 distributed cloud's points of presence. F5 distributed cloud also provides application management and security, including API protection, bot defense, and layer 7 distributed denial of service, very much needed for AI inference models. All this happens automatically and is managed with a centralized SaaS console. Next, we are going to see in more detail how this works. In this demonstration, the customer edge component uses the pod deployment type, in this case, in OpenShift. This only requires to have the performance operator installed in order to use huge pages. In the diagram, it is shown the traffic flow, and I'm going to describe each step starting with the request towards the VLLM inference service. In step number 1, a request is sent to the inference service VIP. In this example, this is inference.demos.bd.f5.com. Then, the DNS resolves this to an F5 distributed cloud anycast VIP address. By means of internet routing, the request reaches the VIP in the closest point of presence of F5 distributed cloud. In step number 2, F5 distributed cloud validates the request and applies security policies to the traffic. Then, F5 distributed cloud load balances towards the customer edges where there are origin pools for the applications. In step number 3, the traffic reaches the customer edge inside the OpenShift cluster by means of a pre-established, transparently configured tunnel using TLS or IPsec. Step number 4 is the service discovery that is done periodically. The VLLM model is deployed with OpenShift AI, which uses kserv. In this case, service discovery is done using DNS inside the OpenShift cluster. This DNS service discovery is done because kserv deploys an external name service for each VLLM model. This VLLM external name service is actually a DNS alias of the Istio's local ingress cluster IP service. In step number 6, this service load balances between the available Istio instances. And finally, in step number 7, Istio ultimately sends the request to the AI model pods. This traffic flow helps understanding the configuration we are going to do next. Although this flow might seem complex, the actual configuration in distributed cloud is extremely easy. The configuration is as follows. In OpenShift AI, we will deploy the inference service and we will take note of the internal endpoint that will be used by Exi later on. Then, we will deploy the distributed cloud customer edge in OpenShift, which is a single YAML file. Next step is to configure the advertisement in distributed cloud. For this, first we will define a health check for the AI model. Then, the origin pool with the internal endpoint we took previously, and finally, we will create the VIP for the internet advertisement. At this point, we can finish refining the configuration by adding security controls. Let's see this in action. We start by creating an inference model in OpenShift AI. This requires a data connection, which in this case is an S3 bucket. This is used to store the model of the inference service. The inference service also relies in a VLLM serving runtime. We can use any of the predefined templates in OpenShift AI, or in this case, I have created a custom one for a VLLM model which doesn't require a GPU, good enough for POC purposes like this demo. What it is really important for advertising the inference is the endpoint used. In this case, given that the customer edge is inside of the OpenShift cluster, we only need an internal endpoint. This allows to keep the inference model isolated from the internet and only exposed through distributed cloud. To deploy the customer edge in OpenShift, follow the page shown in the screen. More precisely, in this demo we use the Deploy as Pods option, which requires the performance operator to be previously set up. Installing the customer edge as pods is easier than a VM because the images are downloaded from the internet. It is just needed to apply the provided YAML file as shown in the pop-up window. To advertise the model to the internet using distributed cloud, first we are going to create the health check, where we specify the desired timers and crucially the host name and path. In this case, the host name is the inference model's endpoint, and the /health is the path to verify that the inference server is up and running. We can also specify HTTP2 as the protocol to use because the use of Istio by OpenShift AI. Next step is to configure the origin pool by specifying that the origin server is going to be discovered by means of using DNS and the OpenShift AI endpoint, the site, and the only interface the customer edge has in OpenShift, which is named outside. Below, we specify the health check we just created. And noticeably, in the TLS configuration, we must disable S3 verification because the default Istio configuration uses self-signed certificates which cannot be verified. Finally, we will advertise the Internet Anycast-enabled VIP by means of creating an HTTP load balancer. In this, we specify the name of the service, and by using the HTTPS with automatic certificate option, the DNS records and TLS certificates are automatically created. Also, we allow legacy clients to access the service with HTTP1, and we also perform the typical HTTP redirection to HTTPS. Next, we specify the origin pool just created. We could then specify all security options, which we skip for this demo, and we go to the very end where we specify the internet advertisement. With just these few clicks, we made our service available in the internet. Lastly, we verified that we can reach the model through the internet using Postman. In this example, asking the AI model, what is a meter? We can see the response in the bottom. To finish, let's see how this looks in the dashboards. This is the top-level dashboard for the VIP just created, which gives general status health and the statistics of the traffic handled. If we click in the VIP itself, we can obtain more detailed statistics, information about the source of the request, etc. By clicking in the Origin Servers tab, we can see the status of the health checks and the result of the DNS service discovery of the AI endpoint. And with this, we finish this demonstration on using distributed cloud to expose an AI model hosted in OpenShift AI easily and securely. I hope you have enjoyed it.